Okay, in this problem, we're going to be looking at a situation where we have investments growing, and we're also adding additional funds on a regular basis. We're still going to be using this idea that our rate of change is going to be equal to the rate in minus the rate out. Okay. In this case, we're not withdrawing any money, so it's just going to be our rate in. All right. So if we take a look at the problem, her investments are growing by 1% each month, and she invests $500 of her salary each month. If she started with a $500 investment 10 years ago, how much are her investments worth now? Okay, so we can think of this in sort of two different ways. In the first way, we're going to say her rate in is, we're making 0.01 times however much she had, plus $500, where T here is going to be measured in months. So what we are adding to this account, each month we're going to be adding 1% of what was there, as well as this $500. Okay. All right. If that makes you a little uncomfortable, we could also build this using that difference equation model. So thinking of having P of n plus 1, how much she has in month n plus 1, as 1.01 times what she had in month n, plus that additional $500. And if we were to kind of chunk this up, thinking about, if we look at the change over that month from month n to n plus 1, we see that 0.01 times P of n plus 500. And if we are kind of imagining this happening at a continuous way, if we, instead of coming back 1 month later, if instead we said, okay, we're coming back half a month later, or whatever this small time scale is, delta n portions of a month later, we can think of the growth due to interest growing at delta n, and instead of depositing the whole $500, depositing delta n of it. And so we end up just multiplying this by delta n. Now dividing across by delta n gives us P of n plus delta n minus P of n over delta n. Okay. And in the limit, we arrive at that same equation that we had up top. P dt is 0.01 P plus 500. All right. So let's take a look at how we solve this problem. So we were assuming that we started with an investment of $500 10 years ago. So let's let that initial investment 10 years ago be our starting time. Okay. So we're going to be using this equation dp dt equals 0.01 P plus 500, and P of 0, our initial investment, was $500. All right, let us solve this equation. I'm going to use that it's linear. So our integrating factor is e to the integral of negative 0.01 is e to the negative 0.01 t. We multiply both sides by our integrating factor. Oops, 500 e to the negative 0.01t. And then we integrate both sides. So that undoes this derivative. And on the right-hand side, we have this integral to do. So we have e to the negative 0.01t divided by negative 0.01t. So that's the same thing as multiplied by negative 100. And then we have plus c. Right. We can multiply across by this exponential. Since it's got a negative power, we're going to multiply across by the exponential e to the 0.01t. Okay, and so we can match our initial condition. So we have P is equal to a negative negative 50,000 plus C e to the 0.01t. And P at 0 was equal to 500. So that means that our C is going to be equal to 50,500. Okay, all right. So this is our model. Putting in that C value. All right. And this tells us what we expect to see in the account for any T. Shauna started this process way back 10 years ago. If we're thinking about it, everything is expressed here with units of months. So 10 years ago is 120 months ago. So if we want to know how much her investments are worth now, let's evaluate this function when our T is equal to 10 years times 12 months or 120 months. So our time now is 10 years later. And because all of our rates were expressed in terms of months, we're going to be looking at 120 months. This is negative 50,000 plus 50,500. And e to the 0.01 times 120. Or negative 50,000. Oops. Negative 50,000. That's 50,500. E to the 1.2. All right, and let's take a look. Okay, so putting this into a calculator, we get about $118,000 in her account. And we can see how much of this is money that's grown from our investment. So she deposited 120 months worth of $500 per month. Which comes to a grand total of $60,000. And so her money has almost half of this money is coming from that growth. Fabulous.